Hello grade 12, welcome to my channel. Let us have a look at this question paper. This was written in KZN in the Term 1 exams. Of course, the intentions here are twofold. One is for those people who wrote this paper, who are part and parcel of my memberships. Is it memberships? No. Who are just subscribers in the channel and supporters, of course, to then see how best to approach questions in this paper. Of course, here and there I can commit some mistakes or perhaps be completely lost. It happens. So don't shy away from helping out by suggesting better ways or better to correct a mistake that you notice. And of course, for those who are still to sit for their Term 1 exams, this can help as a way of knowing exactly where to hit so that the chances of really succeeding become higher and higher. Otherwise, for my students, you know guys, we worked on this partially in the class, so I'm going to try and do the whole thing just in case some of you are facing exams and you won't be able to attend tomorrow, so that we can finish what we started. So the intentions for my students is to sort of provide a revision of what we discussed in class so that you don't miss out completely if you had some issues. Of course, guys, instructions are very important, but I'm just going to jump for the jugular at this point. I've been highlighting exactly why these are so important. So essentially, decimals is 2 decimal places, or we should not have them at all. 2 or more, or none at all. And of course, if we are to give some justifications or motivations, they need to be brief, but they can actually take anything that is applicable. All right, 1.1, folks, we know that there's only one correct answer. Of course, don't do it the way I'm doing. Read every statement, every word, and ensure that you understand. But the main thing here is to suggest that even if there's many answers that you can see, you just choose one. But chances are, if you see more than one correct answer, the others have something wrong in them. So be very careful. Right, anyway, 1.1 reads, which one of the following physical quantities? We've got vector quantities and scalar quantities in grade 12. Now, is the rate of change of momentum? Now think of the impulse momentum theorem. Right? Now when we make the force the subject, and mind you, this force is the resultant force. Spare that. I'm not writing it. If we divide by time, the moment we say the rate is when we say something divided by a unit time. Now we can see that that represents a force. And in essence, we're talking about Newton's second law in terms of momentum. So obviously, guys, this is D. It's either you know or you don't. Okay. Next question says an object is dropped. The moment we drop something, it means its initial velocity, u, is 0 from the top of a tall building. After time t, the object's momentum is p, all right? What will the momentum of the object be after 2t? Right, and the famous statement again that we always wait for, that we should ignore the effect of air friction, because what does this mean? This statement implies that our resultant force here is Fg, right? And if it is Fg, this leads to the gravitational acceleration. This is all downwards. And in essence, we are doing VPM, vertical projectile motion. Right, now let's deal with this. Obviously, we want to define P, right? But now for us to get this, we're going to say find let M be the mass of the object. This is if you are dealing with you know, those questions in structured questions, right? So eventually we want the velocity, right? So we know that the final velocity equals initial velocity plus g times time. Now this means our v is going to be initial is 0 plus g is 9,8 and then time is t. So we can see that v is nothing but 9,8 t. Now this tells us p, we know that it's mv. P is going to be the mass, as we said, we're letting it be m. The velocity is 9,8 t. Therefore p is nothing but 9,8 mt. So this is the definition of p as it is given. So with these kinds of situations, guys, you always have to do this. Now let's look in the second instance. Now folks, a math student or a physics student needs to understand that if the initial velocity is 0, basically what we will see here is that v is directly proportional to t. Why? Because this is what survives the onslaught when 0 is in. Remember, this is a constant. So you think about v being equal to 9,8 t essentially. And this is as good as the equation y is equal to mx. Do you see that? So who's the variable? It's t. Who's the gradient? It's m. This time around, it's the constant. So if you are quick, you can already see that here the velocity in the second instance is just going to be 2 times 9,8 t. Because if the time increased to 2, and so will the velocity. So again, guys, this is either you are sharp or you are not. Okay, so what do we know is that mv is going to be equal to the mass into 2 into 9,8 t. We want it to look like that. So mv is, we're going to take 2 out and then leave this one as m. No, we let m stay inside. This is going to be 9,8 mt. So that if we have mt, we also want mt. Right, perhaps not complete, but we want 9,8 mt, 9,8 mt. So don't rush to calculate that. So what do we see? We see that our mv is 2. But what is 9,8 mt is p. So the answer is 2p. So guys, you need to be very quick with these things. And of course, only experience counts in these circumstances. So there's no guessing this. But of course, if you didn't want to use this phenomenon by understanding the equation, you can go on and still use the equation as we have used it to find the velocity in the second instance. You will see that you'll still end up with the same answers. But I'm just trying to show you guys how to be effective now that we've been studying, learning, and practicing. 1.3 says a boy pushes a heavy box across a rough floor. That means we've got friction here with a constant force of 250 newtons. The box experiences a constant frictional force, as we expected, of 50 newtons while it is moving. Now obviously, if you draw some free body diagram, I'm getting used to this free body diagram business. And of course, these are the forces acting on the box. It's going to be kinetic friction and the applied force. Obviously, these are imbalanced, so the resultant force is going to be in the direction of the original. Mind you, this is 50 newtons, this is 250 newtons. Now this is going to be 200 newtons in the direction of the dominant force. Right. It says now the magnitude of the force exerted by the box on the boy. Now remember, Newton's third law says for every action there's an equal but opposite reaction. Now this has nothing to do with the resultant force. Okay, so this means according to Newton's third law, action and reaction coupling, so the answer is C. Of course, many of you would have been caught pens down by the resultant force. Not this one per se, but the resultant force here would have really driven you around in circles. So most likely students chose the resultant force here and they failed. So you need to know, guys, the principles. So understand the principles like you know your name. Next, 1.4 says, consider the organic compounds 1 to 4 as shown below. So we can clearly see that these are all alkynes because of the triple bond between two consecutive carbons in the chain. Right, so what do we see? This one has how many? 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3. So if we were just to write the IUPAC names, this is going to be but 1-ine, right? Because we always try to use the lower number of the carbon participating in the triple bond. Here, this is going to be pent. Now this is on the carbon 2-ine, right? This one is going to be but 2-ine because now that is symmetrical. This one is just propyne. There's no saying prop 1-ine because even if we change the position into the other position for the triple bond, still in the first carbon. This is just practicing. Now the question is, which of the compounds above are positional isomers? Of course, if they are to be isomers, they have to have the same number of carbons, same number of hydrogens, but perhaps a different position of the triple bond. And these two are truly isomers. So this is 1 and 3. Nice and easy. Now 1.5 says, in which one of the following alternatives are the three compounds listed in order of their increasing vapor pressure? Right, we know that vapor pressure is inversely proportional to the boiling point. Now the one with the highest boiling point, it will have the lowest vapor pressure. Now if you've seen pentanoic acid, pentanone, and pentane, definitely this one at a particular temperature, perhaps this should have been said, at a given temperature, because we cannot assess these molecules at different temperatures altogether. It has to be the same temperature, but whatever it is. So already pentanoic acid has stronger intermolecular forces, therefore it would have the highest boiling point. As a result, it has the lowest vapor pressure. The next one is the next with the higher boiling point, therefore it will have the second, or moderate vapor pressure. An alkane is definitely going to have the highest vapor pressure at a particular temperature because of containing only the weak London forces that are of the same strength as the other two, but the other two in addition have hydrogen bonds. The first one having two sides, the second one having only one side. So as a result, A is the correct answer. Now if we were to list them in their decreasing order of vapor pressure, we would perhaps have pentane, pentanone, yeah, this would be the one if we were to look at the decreasing order. So get used to understanding this. Otherwise, these ones are completely nonsensical because right. 1.6 says an organic compound X has the molecular formula CH8O2. Now, once you see a general formula like those of alkenes plus 2 oxygens, there are only 2 molecules that you are thinking about. It's carboxylic acids or esters. because these are functional isomers. Right, so please know these things, guys. There's no excuses you can put forward for not knowing these. Now let's see, when X is heated, right, it's heated in excess ethanol. Now ethanol being a primary alcohol, in the presence of sulfuric acid, we know that this one acts as a catalyst so that we can use less heat. A sweet smelling compound forms, right? So we end up with a sweet smelling compound. Now obviously this sweet smelling, once you hear that word, this is an ester, and if we were to write its IUPAC name, always start with the alcoholic end part of it. So this is going to be ethyl. Then we come to this one, there's 4 carbons here, so this should be butanoate. Right, good. And of course, what smell is it going to give off? It smells like pineapples. Pineapple smell, or scent, whatever you want to call it. Right, please know these scents, guys. Know these scents. In our textbooks back in the days, there was a mention of what these smell like. I don't know nowadays, but it can surprise you sometimes if it is still the case. So try to research as well, guys. Don't limit yourselves to the textbooks, so that your knowledge is strong and powerful. All right, we are told further that this compound X, when it reacts with sodium carbonate solution, now this is a base, a weak base, carbon dioxide is produced. Okay, now this already confirms that this compound X is a carboxylic acid, because we know that when we react an acid and a base, what do we produce? Salt, water, plus carbon dioxide. Why? Because we reacted a metal carbonate and an acid. So this is essentially one of the products, not the only product. Okay, so we know that technically only an acid can take part in an acid-base reaction. Okay, the question is, which one of the following is the IUPAC name of the compound? We already did it, guys. So, compound X. Compound X is the butanoic acid. So the answer there is our lovely B. Alright, so that is essentially what this is. Now, I told my students something interesting about these molecules, because some of you think you just have to cram this to pass through. Now, let me tell you, the ester formed here is the ethyl butanoate. Sometimes we call this one an alkyl alkanoate. Now, what I want to talk about is the alkyl group. Now, what is an alkyl group? An alkyl group is any of the saturated hydrocarbons. Hear me say, any of the saturated hydrocarbons when it has lost its single substituent. For example, take methane. When it loses this hydrogen, this is lost. That's a substituent, isn't it? It leads to an alkyl group where there is a missing substituent. And this position right here makes it highly reactive. Because it wants to be stable. Remember, once something is in ionic form, it means it's unstable. Of course, there are some stable ions, but some substances do not like it when they are essentially incomplete, because they only become stable once complete. So it makes it highly reactive. Of course, an alkanoate, it's any of the carboxylic acid once they lose a hydrogen, right? But these ones, only once they lose a hydrogen, they give us, for example, ethanoic acid. When it loses the hydrogen, we get what we call ethanoate ion. Okay, so that is essentially the idea. Now guys, why should we know these things? It's because if you think of molecules like cyclophosphamide, this is a chemotherapeutic agent. It resembles esters. And as you would know, certain medications have a certain smell, and there's usually an ester-like component to them. Okay, so it resembles esters, that's the first thing. But of course, we call this molecule an alkylating substance, meaning it adds an alkyl group. Once you say it's alkylating, it means it adds an alkyl group to molecules, right? And as you can see, alkyl alkanoate, so esters are very good for this because they are rich with this tail end, or whatever you want to call it, that hydrophobic end of it that comes from the alcohols. Then that part can easily be broken off and put elsewhere, so it can give it off whenever the chance comes or when it is under pressure. Now, what do alkylating agents do? These ones inflict DNA damage to cells, right? How do they do this? We can say at this one is in particular at guanine. Is it guanine? Guanine bases. And of course, these alkyl groups, they will prevent the cross-linking, right? Which then prevents replication and transcription, right? So this cell is then signaled to die. Call it apoptosis. So all I'm trying to say, guys, do not think we are playing when we're teaching you these things, and do not cram your way around matric. You will go to varsity and get embarrassed because you won't have time to sit and study things over and over again. There, you only get one chance to study. Go and get one chance to write an exam, and if you fail that module, you're coming back the next year to repeat it. Now, there's no money to play, guys. Education is way more expensive than it was with us back then. All right? So be very careful. Knowledge is power, and there's no excuses you can bring. If you don't study and you don't know your work, you're always going to be found out. Right, so alkylations, or should I say adding alkyl groups, is usually what causes DNA damage. Remember, cells need to divide. They need to produce proteins to maintain their cell integrity, to replace cell membranes and all those things. If they cannot do DNA transcription, none of those processes are going to take place. So the cell loses energy. The cell cannot maintain itself. As a result, it dies. That's how cancer cells are killed. But this, of course, it does this to highly dividing cells. Now, highly dividing cells is going to be cancer cells. It's going to be the bone marrow. That's how we go looking for stem cells there. And of course, mucous membranes, usually. Mucous membranes divide a lot to try and replace the membranes from excoriations and what. Skin cells. and just say mucous membranes, because those ones replace themselves much better. But the ones that get affected the most is the cancer cells and the bone marrow, because they are highly active. Remember, we need red cells, we need white cells to fight off infections. This is why when we give these medications, the suppression of replication in those cells, meaning the production drops, so a patient becomes anemic as well as immunosuppressed. They are prone to infections while killing the cancer, of course. So we are trying to get to research now to find out medications, or should we say agents, that can specifically target cancer cells and leave out the normal body cells. So this is why we are constantly studying what we need to do. Unfortunately, to study these things in human beings is not so easy because of ethical considerations. But anyway, people these days are largely unethical in their conducts. I wonder, why should we really uphold those standards when all of this is really to help them? But hey, we cannot play God. At some point, we let everything slowly evolve until it clicks enough for us to do what we need to do and perhaps bring the answers that we need. Now guys, this basic understanding of these molecules helps you a lot, because this molecule is actually more complex. As I said, it resembles esters because it's not exactly an ester. So we always create what looks alike. That's why we call these synthetic molecules. Because if we were to create what would be a biologic molecule, it would cause more damage than good. So we want a synthetic molecule that may only be used for what we're trying to get it to work. Otherwise, we don't want it influencing other issues within the body. So we're still ongoing with research, folks. I'm just trying to highlight to you guys the utility of these molecules. It's not a joke what you're doing. It actually does apply. All right. Now let's get to question 2, which is mathematics in physical science, right? Right. All right, let's do question 2. Now question 2 reads, in the diagram below, 2 blocks A and B of mass 8 kilograms and 5 kilograms respectively are connected by a light inextensible string. Now what does that mean? It means by being light, it adds no weight into this system. By being inextensible, it means when one block moves, the other block is going to move at the same rate as the other one. That's the essence of that. Sometimes it gets asked, what is the utility of that, or what is the implication of it all? Now, the string is passed over a light, frictionless pulley. Again, why should this one be frictionless and light? Light so that there's no weight considerations again in the system. Secondly, frictionless so that the tension on one side should be the same as the tension on the other side. This is what helps us to then see these objects move together at the same rate. Okay, so these are very easy things, guys, and easy marks to score when asked. Initially, the blocks are held stationary, so that means their initial velocity, u, is 0. At the same position, see, above the floor. Now, we don't know what is the height above the floor. We are not told, but we know that they are at some height above the floor. You can call it delta y. All right. Now, each block is 0.3 meters high. So this is already indicated for us. So same goes for the other one. Now we are told that the blocks start moving when they are released. See, released starting from rest. We just wanted to hear this word as well. Ignore air friction, because we know that these objects are moving through air. So essentially there would be air resistance opposing any direction of motion. Most likely the direction of motion is going to be down for this block because it's heavier than the other, but the direction of motion would be up for the other one because it would be pulled by the 8 kilogram block. Okay, now first question. 2.1, we need to draw a free body diagram of all forces acting on block B. Now block B is moving upwards, so we know that its weight is less than the tension. This one is not straight. Lord, let me just do this. Hayi man, mandingayenzi wena sundiqhela wena. Sikantlwayela. Damn it, man. So this one is no. Yeah, this is how it should be. The other one must be short. FG is short, while the tension is much stronger. Why? Because this object is moving upwards. So this is a good representation. Sometimes precision and paying attention to detail. At this point, there is no excuse that can be made for not, trying to be as detailed as possible. Don't know what I'm doing. 2.2 says, state Newton's second law in words. Now we can choose whichever. Right. Anyway, let's just state it in principle. We know that a body will, let's say when a resultant force is applied to an object, the object will accelerate in the direction of the force such that the acceleration is directly proportional to the force and inversely proportional to the mass of the object. Right, of course guys, my writing needs prayers, but well, it is what it is. I'm gonna help you guys. I'm gonna publish this memo in the group, okay, for all these questions. So I'm gonna try to write in such a way that you can see. Of course, not necessarily because you can't read, you can find these definitions anyway. But make sure guys, we talk about an object accelerating in the direction of the resultant force, and we talk about the proportionalities. For those who forget, just look at this formula. F resultant is equal to MA, and specify these proportionalities. If you can try to find words to write this, you are good to go. This is to say, guys, there's no excuse for not getting these marks. As wordy as this principle is, it's very easy to find the words to put it together. Now 2.3 says we need the acceleration of the blocks after they got released. Easy. We're going to first look at block A. If we look at block A, it's going to accelerate down, whereas the tension is trying to oppose the motion, but it's going to be smaller than its gravitational force. So this is the 8 kg block, which is block A. Now, if we look at this, we know that the resultant force equals MA. Now the gravitational force is bigger than the tension, equals MA. Gravitational force is 8 into 9,8 minus the tension, which we don't know. This is 8A. Right. Now we can isolate the tension. So if we do that, it's going to be 8 times 9,8. Okay, 8 times 9,8. This gives us 78,4. Now we're going to subtract 8A. This gives us equation 1. We also look at the next object. The next object is object B. We already know that, okay, maybe we can even stop that. We can say also, we know that for object B, where we did the resultant, those forces, the tension is bigger there. So we know that T minus Fg is going to be equal to MA. The tension is bigger than its gravitational force, equals 5A. If we isolate the tension here, this is going to be 5A plus. Now let's see, 5 times 9,8 gives us 49. So this is equation 2. Yes, Heaven. Now, this thing is doing things to me now. Now this one, guys, there are certain things I like to do, but it just doesn't do. And when I don't want it to do it, it does it, you stupid thing. By the way, we know that equation 1 is equal to equation 2. Why? Because both are talking about the tension. And do you see the influences of our frictionless pulley? There they are. So we know such that, we're going to have 7, 8, 4 minus 8A equals 5A plus 49. Right, we move along. We bring in 5 to the 8, we get minus 13A equals 49 minus 78, 4 gives us a minus 29,4. So therefore our acceleration is going to be that value divided by minus 13. So we get an answer of 2,26 to 2 decimal places meters per second squared. Now we cannot tell the direction here. It's very difficult. So not mentioning direction is fine. In fact, this should have said calculate the magnitude. Because remember, we used both blocks. The other one is accelerating up, the other one is accelerating down. So what are you going to write here? But if they placed a reference, perhaps, say calculate the acceleration of A or B. Now this acceleration in relation to B, it's going to be down. In relation to A, it's going to be up. So it was easier if we were told which block is accelerating. But if it's just the acceleration of the system, we cannot give a direction here because they are both moving in different directions initially. So here we are justified for not answering as we want. Right, guys, so this is easy. If we look at the principle, we get a mark, we get a mark, we get a mark, and we get a mark. So it looks like everything else was our problem. This should have been 5 marks at least, because these are simply calculations. These are simply calculations, but I guess grade 11 types. Right, so let's move on. This one says block A touches the floor a second later. Okay, after the release. Now this is when this just hits the ground, not yet being stopped by the ground or anything, but when it just touches the ground. Otherwise, the moment the ground starts stopping it completely, this one becomes a projectile. It's going to go up first and then come back down and rest, isn't it? So there's going to be that moment, but now we're told that this is when it just touches, so not yet stopped, because if it stops, this one becomes a projectile for a moment, then again everything equalizes, such that now the tension is going to be equal to the gravitational force of that object. Okay, I hope this makes sense. The blocks come to rest as shown, of course, that is after, moments later. Now the question is, calculate the vertical distance d measured from the top of block A to the bottom of block B the instant A touches the floor. Can you see? Before B becomes a projectile for a moment and then later stops. So we want to know how far apart are these boxes. Now these are some of these crazy questions which are literally higher grade. So actually my students nailed it when I couldn't figure it out completely because I kind of made a silly error. But anyway, it is what it is. So this is going to be 2.4. So I have a very bright group of students, guys. They inspire me to do more for them because they are just brilliant. They are not scared. They are brave. And not just brave, they are meticulous. They are sharp. They do their work. Please, whoever is watching and is struggling with these subjects, take the habit of practicing more, studying more, and of course opening your mind to all the things that are around you. But be very careful, don't adopt everything because you'll end up confused. So now guys, how do we plan what to do here? Now obviously guys, when this object is on the ground, if we just look at these two, say for example, if I focus on this reference point on the block and that reference point on that other block, right? If this point is now seated right on the ground, it's kissing the ground, and that one is up there, right? So this means this block has moved this displacement down. Of course, I'm just looking at a reference point because these questions are going to horrify you if you don't know what you're doing. Now, folks, we want to know first, what was this displacement above ground? And we know that this part is going to move all the way until it's seated right on the ground. But we know that these blocks are connected. So however is this displacement moved, it will be exactly the same displacement that this other object has moved up. But now we don't know where they started. That's just the problem. We don't know where they started or how they started. It's a bit of a nightmare, I tell you. So if I can just redraw these boxes and say, fine, let's say here's our ground, so that you can see what I'm talking about. And this block is on the ground now. It doesn't really have to be like the other one. And then that block perhaps is over there. Because remember they were once together, so now it's sitting over there. But now I'm going to assume that they started over here. Let's say this is the starting position. Okay, so we said this object will have moved down this height, which we said was delta y. But then remember the reference positions. We said if they started like that, that position is on the ground. Now this also means this one must have moved exactly the same height from starting position. So this means to go there, we must also have the same delta y. and such that this delta y is equal to that delta y. Because if they move like that, that's how it is. Sometimes if you want to check this, you can take your fingers, place them on the same positions, use your index fingers, then move them the same way up and down, and you will see that from the starting position to where they will end, they will be the same distance above each other, or at least from the reference point. So this is the understanding. Now, first of all, we want to know what is this, because once we know it, it means we will know that. Then we can take it from there. Now let's just use object A, because object A is much easier to use. Object A, we can see that it moved exactly this displacement down. It's not easy for block B for us to tell where was the starting position, but all we know is that wherever it started, that position or that bottom end must have moved exactly the same distance as the bottom end of the other one, because they started from the same position over there. All right, so now let's see. If we want that height, we're going to say here basically v squared. Do I want the velocity? No, we want the displacement. Delta y is going to be equal to essentially delta, what is this? I don't like these delta things. I'm just going to say, why do I care? Okay, I'm going to just say delta y is going to be ut plus half at squared, right? This is the best equation for business. I normally use s for this because this is much easier. But anyway, we just said delta y is going to be equal to initial velocity is 0. The time we were told is 1 second. Then this is plus 1 over 2 into. Now remember, I'm going to choose downward as positive. Doesn't really matter at this stage. So this is going to be 9,8 times 1 squared. So this means our delta y is going to be 0,5 into 9,8. So this gives us sorry guys, wrong substitution. Remember, the acceleration is not gravity now, it's 2,26. The answer was too big for my liking, so this is 0,5 into 2,26. Did we get 2,26? Yes. So 1 squared is just 1, so we get a 1,13 meters. So this means this part of this object has moved down, because that's what we're using. The rest of the box is going to confuse us. But if we choose a reference point, this has moved exactly 1,1 meters down. But remember, this box itself is 0,3 meters. Right? Right. So what does this mean, guys? It means we need to know what is that displacement. Now, we know that this is essentially 1,13 meters. Now, this also means this must be 1,13 meters. Remember, this is just a height after all. Now, what do we need, guys? All we need now is to find out what is this displacement. And this displacement is going to be this guy minus this guy. This will tell us exactly what this distance is. So let's see, what is it? So we can say this minus 0,3, the height of the bottom block. So this is going to give us 0,83 meters. Now, what do we want? We want this whole displacement. What we want is from the top to the top, or bottom to top. Now you can already see it's going to take this guy and that guy. Okay, so this is as simple as that. As you can see, guys, it's a nightmare, but I tried to annotate it better because, wow, it's not such an easy question. This one twists your neck. And this is how we should examine grade 12s. We can't give them grade 11 questions, guys. No. Okay, so what are we going to do now, guys? We're going to say, then, I'm not going to explain anything. I'm just going to say, then D is going to be, this is going to be the 1,13 minus the 0,3. I'm explaining this part. But at the same time, the bottom of the other block, because this was A and this is B, the bottom of that block will be exactly 1,3 from the starting position. We're just going to add 1,13. How to explain this, guys, it's your own problem. For D is, although I can draw a sketch, sometimes in physics you run out of better ways to explain, you just do instead. Remember, this is a subject you can do by observation. Yes, 1,13. So guys, we get a distance of 1,96 meters. So as complicated as it is, if you understand what is happening, then you know what is cooking, guys. Sometimes there are no better words than just actions to get around business here. So of course we get a mark for the formula, guys. Get a mark for the substitution. We get a mark for this business. And a mark for knowing that this would be the same distance. As to where it came from, only God can explain this to you guys, but that's it. We've got our 5 marks in the bag, and nobody is going to tell us otherwise. Alright, so that's it for those 13 marks. As you can see, the last question can really twist your neck. You know, as I said, think about placing your finger, your index finger, with all the others curled, and then you place your other index finger. You place your other index finger with all your other fingers curled together. And then you know that you draw a line where you start. If you move this index finger down, of course, assuming that this object was seated on top of your index finger. Now your index finger is over here. Now it means that index finger is, because they're moving together, if that moved down there. Now remember, this is the bottom of the other one as well. So it means this one will be somewhere up there. Okay, because your index finger will be there. And of course, your bottom of the other box will be there. But from the starting position, we must have moved the same height. So I think this is how best you can try and help yourself during the exam. Because remember, guys, this is why you must never write an exam when you are not prepared. Of course, guys, that's it. Let's move on. Let's get to the next page. So question 3 says, a soft ball with mass 0,3 kilograms is projected vertically upwards from the roof of a 45-meter tall building with a velocity v. So this is a potential question. Now it hits the balcony below with a velocity of 29 meters per second, and it bounces off at a velocity of 13,77 meters per second, and the balcony is 12 meters above the ground as shown below. And the magical statement, ignore the effects of air friction. We want to hear that so that we can be comforted by that the acceleration here is g and it's downward, such that the resultant force is Fg and it's downwards. Okay, Now 3.1 says, define the term projectile. What is it? A projectile is an object that is given an initial velocity and then undergoes motion influenced by the gravitational force only. Nice and easy. This one is very easy, guys. The gravitational force is the only force acting on this object, but it must have initial velocity first to become a projectile. If it was just dropped, technically, by definition, it's not. So 3.2 says we need to calculate, right, the magnitude of velocity with which the ball was thrown from the roof. Now the most important is that even though the object goes up, right, the height it goes up is the same height it goes down, so those cancel each other out. But technically, what is the displacement from starting to the end is this portion. So the displacement here is this one, basically. So this object is being displaced down. So now if we say 45 minus 12, this is exactly the displacement. Let's see. You can say 45 minus 12. This is 33. So this is 33 meters. Now this is that displacement of this ball from the roof to the balcony. So that's what we needed. So we go 3.2.1. We now know that if we're looking for that velocity, we're going to say the final velocity squared equals the initial velocity squared plus g t plus 2gs. Right, because we have everything we need. The final velocity we were given, this is now, remember, with VPM, guys, I always choose positive to be upwards. It makes life easy. The moment you choose downwards, you end up with some scary answers. But hey, if you can handle it, you can. Now remember, when you substitute into these formulas, these are vectors. If it is down, you need to give it its sign back. So this is 29,36 squared. But since these are perfect squares, it doesn't really matter, hey? Now this is what we want. The u squared plus 2 into minus 9,8. Right, the displacement is downwards. So that 33 is minus 33. But to showcase the calculation here, you can just say 12 minus 45. This will give us a negative 33 strategically. Right? Yebo, 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 yes. Right, so now what are we going to do? We will then isolate our u. U is going to be the square root of this minus 29,36 squared minus 2 into minus 9,8 into minus 33. Therefore, our initial velocity is, let's see, what is it? Square root of minus 29,36 squared minus 2 into minus 9,8 into minus 33. So we get a 14. Now remember, this is upward, 14,67. Therefore, you can conclude, remember we used u as a means to an end, but what was it? it was V. Therefore, V is 14.67 meters per second upwards. So you can use an arrow, you can write upwards, but here specifically the examiners wanted the magnitude. So we get a mark for the calculation and the general substitutions and the final answer. Right, so that's how we do this one. So 3.2.2 says we want the velocity with which the ball strikes the ground. So obviously this is the last motion. So this is when the ball is just being displaced downwards from the top of the balcony to the ground. So it's just being displaced 12 meters down. So this is easy. You can use the same formula. V squared is equal to U squared plus 2GS. So V squared is going to be the U. Now this is going to be the bouncing off velocity, which is 13.77 squared plus 2 into minus 9.8. Don't forget we chose up as positive. Now this is being displaced 12 meters down, so this is going to be minus 12. Right, so this implies that our velocity is going to be the square root of all of this. Right, so therefore we know that our final velocity is the one with which it hits the ground. Yes, it would have been negative, but at this stage we are not interested in that. Okay, let's see. This is 13.77. So we get an answer of 20 to 2 decimal places, 61 meters per second downwards. Sometimes you can just use the arrow. I don't know if it is still acceptable, but I guess it should still be acceptable. Formula, substitutions, guys, and answer. But remember, this answer is complex. We want the magnitude in the correct format, 2 decimal places. We want the correct SI unit as well as the correct direction. So if any of those are missing or is not correct, the last mark gets lost. So be very afraid of easy questions like this, because the level of strictness in the marking is amazingly strange. Some of you feel like the teachers hate you when they don't give you full marks. Like, I got the right answer, but did you present everything correctly? So guys, get into the habit of being as precise as possible. And while being precise, you need to be as complete as you can. Right, let's get to the next question. Now, of course, 3.3 is one of those. It's one of those. There's always those questions that are going to put you through thick and thin. Let's hear. It takes 8.2 seconds from the time the ball is released, not released, but projected. What was the story here? It was projected, not released. You can't release it upwards. There's no way. You only release it downwards. So from the time the ball was projected from the roof until it strikes the ground, we need to calculate the resultant force that the balcony surface exerted on the ball. Now, I am a bit unsure about this question, because if we want the resultant force, remember, the resultant force is not because of the surface alone, but it's going to be the surface and the gravitational force. But if someone says the net force that the balcony exerts on the ball, this is wrong. You cannot say the resultant force, but you can just say the force. So that statement must go. Because if you want the resultant force, it is not by the balcony. It is because of the balcony and the weight of the object. So we can either say we want the resultant force on the ball or on the object that is exerted due to the actions of, I think to say the resultant force by the balcony, although it's put in bold, it's giving wrong information. Remember, resultant is something that comes out of two things or three things, but it can't just be one thing, I'm not sure here if I'm happy. Okay, it can be one thing, it can, but would we then say the resultant when we know there's more than two forces? Because as the ball is about to leave the balcony, we know that there's going to be force by the balcony. We can even call it force applied by the balcony, and then there's going to be its gravitational force. But since the ball is going to accelerate upwards, it means that force is greater than the gravitational force, such that the resultant force is in the direction of the big force. This would be the resultant force. Now, we can see the resultant force is not due to the balcony alone. So I'm not happy with this line of questioning. These are some of the issues that should not be allowed, guys, to be in these question papers. And please, guys, I don't know how many times we've been mentioning these things, that people who examine must not be amateurs. Number one, if at all you are grooming someone with a potential, proofread what they do. Subject yourself to that and discuss it with them so that they become better, okay? It's not about just trying to elevate people. They have to come up, not be elevated and parachuted. Secondly, there's what we call quality assurance. People who are hired or are at that position, they need to be able to sit down and do their paper like they are matriculants, okay? So that they can determine whether this question paper is fairly long. Will they be able to finish within the given time? Because if it can take an expert longer than is expected to answer a question, already students are not going to be able to do that in a short while. That is just a given. Except for students who are shown the memorandum. They will come and transcribe. Definitely they will. It takes a few, 2 or 3 who are exceptional. But I can tell you, they themselves will struggle in understanding how to put things at first, although they will eventually do it. So I don't know, guys. But I get angry when this is the case, because for me, this is what we want. This is what is the question, not the resultant force, because that resultant force is not due to the balcony alone. So anyway, I'm going to show you 2 answers. You will choose the correct one. But for me, the intention here, if we say by the balcony, then it's not the resultant force on the ball, but it's the force applied by the balcony. Anyway, let's get to business. So what are we going to do, guys? Now, we need to do this. Now, for us to do this, we can see that there was a change in momentum, right? The velocity with which the ball struck the balcony is different from the velocity with which the ball essentially bounced off the balcony. So there was a change of momentum. So this means we are at liberty to use our resultant force times the impact time, giving us a change of momentum. So this helps us a lot. So we need to apply that as a means to an end. If you like, you may calculate the acceleration during this change of velocity, and of course find the time. After you've got the acceleration, then you can use the resultant force is equal to ma. But at the same time, the target would be to find the resultant force, which will then lead us to these forces, because the resultant force here is going to be the force by the balcony minus the gravitational force. So that's the idea that needs to come to mind here. Okay, so let's get to business before we talk too much. Now, what are we going to do, guys? Now, the plan here is to say, what is the time duration from launch until this hits the balcony. We're going to say this is time t1. Then we're going to call the time of impact and change of what. We're going to call it t, let's call it t2, right? This is the contact time, which is what we need. This contact time comes and sits over there. That's what we want. And then we're going to say the time from bouncing off the balcony to reaching the ground. We're going to call this one time t3. Okay, so that's essentially how you try and plan these things. So now what are we going to say? We're going to say let the times from top of building to balcony, we can say contact time, and from balcony to the ground. B, we're going to say T1, T2, and T3 respectively. Sometimes it helps to sort of like be strategic, try to be a bit more conversational, I suppose. You know, because sometimes this simplifies how you're going to do the work. Now let's get T1. That's what we want to know. How long did it take for the ball to reach the balcony from launch? So this one is easy. We can just say, well, for T1, it is such that the final velocity is the initial velocity plus g times t. Now the final velocity is the one with which it hit the balcony. So this is going to be minus 29.36. We chose up as positive, so stick with that. Now u is the velocity from the balcony, which is 14.67. Plus, this is minus 9.8 times the time. So this implies that our time, in fact, this is time t1. So we can say time t1 is going to be, it's going to be 14.67 plus essentially 29.36, all divided by 9.8. So what did I do here? I transposed that to that side, transposed that to the other side, and divided by 9.8. So let's see what T1 is. So I've got 14.67 plus 29.36 all over 9.8. So we get here 4.4929 seconds. Let's just do as many decimals as possible to prevent trouble. We can say likewise T2. Okay, T2 is not going to give us much, but T3. Because T2 is going to be a means to an end. We're going to use this to get it. Now let's see, we're going to have the same issue here. V equals U plus GT. Now, what is the V here? This is the V of bouncing off the, the V is the one that we hit the ground with. Now, the velocity of hitting the ground is 20.61. So this is going to be minus 20.61 equals, the initial velocity is that one of bouncing off the balcony, plus into minus 9.8 times t 3. So this implies that our T3 is going to be, again we do the same, it's going to be 13,77 plus 20,61 all divided by 9,8. Excuse me. So we've got 13,77 plus 20,61 divided by 9,8. So this gives us a time of 3,5082 seconds. Okay, so that is the T3. We can say then, by the way, what are we trying to find? Yo, it's a lot, ne? We can say here, however, we know that T1 plus T2 plus T3 should be 8,2. That's the entire time of motion. So this implies that 4,4929 plus T2, which is the contact time, plus 3,5082 should give us 8,2. In this case, I'm interested in T2. So T2 is going to be 8,2 minus the sum of these two, 4,4929 plus 3,5082. Right. So this gives us a value of 0,1989. This is seconds. Now that we know the contact time, what are we going to do, guys? We can now go on and answer the question. So we can say then, we know now that we want the force by the balcony. We understand that the resultant force times the contact time gives us the change in momentum. Now the resultant force is going to be the force by the balcony. Let's just say F. Force by the balcony minus the gravitational force, right? Into delta time. Time of contact is going to be change in momentum. Change in momentum is just the mass into final velocity minus initial velocity. Nice and easy. So this one is going to be F minus Fg. This was 0,3 times 9,8. Right? Right. This is going to be 0,1989 equals 0,3. Final velocity is the one with which it hits. Sorry, it leaves the, it leaves the balcony. So this is going to be 13,77 minus the initial velocity is the one with which it hits the balcony, 29,36. Right. So the force by the balcony is still what we want, minus, let's see, this is 0,3 times 9,8. This gives us 2,94. Right. I do think at this stage, okay, let's leave it. 0,1989 equals, let's sort this one out. This one is going to be 0,3, but I feel like I'm going to do too much. Let's just leave it as it is, 0,3. Perhaps we can just break the big bracket, 13,77 plus 29,36. Now if we isolate our force here by the balcony, it's going to be this 0,3 into 13,77 plus 29,36, all divided by the time, which is 0. Okay, maybe let's push you back a bit. Let's back it up a bit. It's going to cause us problems. So this is all divided by 0,1989. We move that one over, it's going to be plus 2,94. So we know that the force exerted by the balcony is going to be, let's see, 0,3 into 13,77 plus 29,36, right? All divided by 0,1989, then plus 2,94. So this gives us a force of 67, to 2 decimal places, it's 99 newtons. Now remember, they said the force, if it is positive, it's going to be upwards. Right, so that's how we did our job here, guys. Of course, we did this under the impression that there's going to be two forces here, Fg and the F by the balcony. Now, if the question was just on the resultant force, guys, if that was the case, we would be solving for this bracket only. Now, if we solve like that, we just simply take this expression. We divide by that, and we get our answer. Because I'm not too sure what this question is asking, but for me, I think this is what they're looking for. But, skeptically as I am, or we can say, this is questionable, of course. We can say the resultant force is going to be 0,3 into 13,77 plus 29,36, all divided by 0,1989, right, which would be equal to, let's see, so the answer that we get is 65,05 newtons upwards. As you can see, the resultant force would be like that, if that's what we are looking for. But I am not sure if this is correct, because this is not the resultant force by the balcony alone. So obviously thread carefully here. But I think what the examiner wanted was to say calculate the force by the balcony. And guys, in this channel of mine, I've done questions of this nature multiple times. There's a question from IEB that I did of this nature. There was one from May, June 2022 that I've done here. It was about some, what is it? There was something dropped from a helicopter and all that. This is exactly the idea. So those of you who really look around well and practice well, this was an easy thing. As I often say, you will always get an advantage if you pay attention. Of course, this, guys, was an essay. It's even more than 7 marks, in my opinion. But since we've been getting marks for formulae and all, but I think we can give one here and get this time and that time, 1, 2, 3, 4. And then we're gonna say 5. This is good. And then we can say 6 for substitutions and the answer. But remember, the answer must be the correct magnitude, correct SI unit, and a correct direction. And of course, if this is the answer, that's it, but I doubt. But in any case, it is to be considered, because if someone said resultant force, what are they trying to tell you? Perhaps the resultant force. but I don't think so. That's why my main calculation is not about it, because I know it is unlikely to be the thing. As we can see here with our diagram, which you must always think about when solving issues of Newton's laws of motion. Anyway, guys, that would sum up the total of those 16 marks, which you can see that the last one, if you don't understand your work and you don't know what you're looking for and you don't know how to use it, it takes you out straight up. Okay, it takes you out. Okay, let's get to the next one. So we've got question 4. Oops, I must kill something here. It's always lucky I miss this nonsense. Damn mosquito. Now, a car of mass 900 kilograms is stationary at a traffic light when it is hit from behind by car B of mass 1,100 kilograms traveling at 9 meters per second to the right. Okay, immediately after the collision, the car A moves to the right at 10 meters per second. Okay, so there has been a change in momentum for that object. Right, so this one is easy, guys. Standard questions. Usually this is where you come and get marks. State the law of conservation of linear momentum. We know that total linear momentum in a closed system remains constant, or you can say is conserved. Okay, maspalega clinch. Total linear momentum in a closed system remains constant. I tried to write nicely, but it just didn't happen. Of course, some people choose the word isolated system, but yeah, whatever, guys. Whoever teaches you, try to follow them for the term exams, because you are stuck with them. But when you're writing the national papers, some of the things they tell you, you can ditch. They will not know, okay? Right, because some people can be absolutely ridiculous. Make their preferences your preferences when in fact they don't matter. Anyway, let's leave it at that. Calculate the velocity of B immediately after collision. So we're going to use the principle of conservation of momentum. We can say sum of momentum before must be the sum of momentum after collision. So this implies now the momentum of car B, obviously we're going to choose to the right as positive. That's the only direction of motion we had here. So obviously for A, let's look at car B. It's going to be the mass of B, initial velocity of B, plus the mass of A. Okay, the subscripts are not quite. Then this is the mass of A times the initial velocity of A. Do you see when you use V and U, it's so easy. This is going to be the mass of B times the velocity of B, the final velocity, plus the mass of A times the velocity of A. See, nice and easy, not too many subscripts here. They need to think about this nonsensical thing that they do. Okay, anyway, let's leave it at that. Car B is 1,001 kilograms into its initial velocity was 19, plus this one was 900. Its initial velocity was 0. Did I say plus? Ooh. equal to, now the mass of B again is 1001, no, not 1001, but 1100 times the velocity of B, which is what we want, plus the mass of A, say 900, the velocity with which it moved was 10. So we can already see, guys, here that essentially the velocity of B is going to be 1100 times 19. We move this one over, minus 900 into 10, and then we divide this by 1100. Therefore our velocity of B is, so this is nice and easy, 1100 into 19 minus 900 into 10 divided by 1100. So you can see the speed has decreased, which makes sense. 10,82 meters per second. Now the question said velocity, so this is positive, is to the right. So don't forget, guys, if you treat vectors with respect, vectors will never misbehave around you. Of course, we get a mark for the principal, substitutions. Yeah, doch, this one, final answer, maybe we can say right hand side, left hand side, whatever. 4 marks in the bag. Now let's move 4.3. 4.3 says modern cars are designed to partially crumple on impact. A crumple zone is a specifically designed part of the motor vehicle that is designed to deform or collapse during collision. Now explain how crumple zones are used as safety measures in motor vehicles. Right. Of course, this has to do with our infamous formula. The resultant force delta T is equal to change in momentum. Now, if they crumple, they increase the sky. If we increase the sky, we know that we're decreasing the sky because those two are inversely proportional. So essentially, assuming that we keep the momentum the same. So that's the idea. So that's how we use them as safety measures. So we can say the crumpling of the car, right, of the car would, or in fact increases, the crumpling of the car increases the contact time such that the resultant force is decreased, is as small as possible, is as small as possible to limit damage on impact. Okay, that's what you can say, and you can even show here resultant force is equal to change of P over change in time, right? And you can even explain that the resultant force directly proportional to 1 over time with P as a constant. Okay guys, that's essentially the idea here. And of course we know that from Newton's third law this can go on and on, but we just needed to explain that basically we are increasing the contact time and essentially decreasing the resultant force so that there's less damage on impact. Alright, so I think there's not a lot here. It's just 2 marks, guys. Talking about those 2 things is more important. Sometimes be as precise as possible. Sometimes you may think you are being cryptic, but sometimes it's good enough. Determine by means of a calculation whether the collision between car A was elastic or inelastic. So now this is good. Easy, 5 marks. This one is a standard grade question, guys. Anyone who fails this one must just come here. I want to deal with them. Okay? Honestly. So we know that in a closed system, this one not necessarily closed but isolated system, the sum of EK before, okay, let's not say in, but we need to prove this. This is equal to half MB VB squared plus half MA VA squared. Perhaps we say U, because that's the initial stuff. UA squared, which is going to be 0.5 into 1 into 19 squared plus 0.5 into 900 into 0 squared. Let's see how many joules is that. So it's literally that of the bigger one. Okay, let's do the things all squared. So this gives us a total of, yes, that one, 198,550 joules. Now let's see EK, sum of EK after. This is going to be half MB VB squared plus half MA VA squared. Now this is 0.5 into 1100. That velocity, what did we get? It's 10.82 squared plus 0.5 into 900 into 10 squared. Let's see what that is. So we've got 0.5 into 1100 into 10.82 squared plus 0.5 into 900 into 10 squared. Okay, so what do we get here? We get 109. So this is 109,389.82 joules. Right. So what did we have here? We've got 198,550. This time around, we have this time around we just have 109, so that's less. So we can just say here, therefore, sum of EK before is not equal to the sum of EK after. Therefore, the collision, how do we write the collision again? Double L. I'm sleepy now. The collision is inelastic. Nice and easy, guys. This one, we always have to prove it by means of a calculation. So this is 5 marks. Okay, formula, substitution, and then this statement and the answer. 4 marks. We can give half a mark for each. Crazy, but it is what it is. Now let's do this one. There's always going to be some higher grade question that needs an explanation applying some principle. Let's find out. A traffic officer arrives arrives at the accident scene and makes the following observation. In a head collision involving two cars of different masses, the risk of passenger injury in the heavier car is lower than in the lighter car. Now use principles of physics to explain the observations made by the traffic officer. This is going to use Newton's third law. So the force that this one applies onto the car is the same force that the small car applies on that big truck. But the problem is that now the big truck is much heavier, and as a result, the impact on it is not going to be the same as on the smaller car. But the smaller car is going to absorb all the force, and being smaller and lighter, all the damage is going to happen to it. So that's the idea, guys. Is there anything else? I'm thinking now, is there something I should say? So the one who crumbles most is the smaller one, or the weaker one. Right, so let's take that and say, we can say according to Newton's third law, can say according to Newton. Oh, this question was famous though. You would always have to say the force exerted by the big car is equal but opposite to that the car exerts or exerted on the bigger car. You can say due to the smaller mass of the due to the smaller mass of the smaller car, it will have the greatest damage on impact as its inertia is smaller. Right. Remember, the bigger truck has a bigger inertia. So even if this force that this one is trying to resist with is being applied, but that one needs more than the other one can apply, you know. So essentially, I think that is the case. But again, we know that mass is the function of inertia. So wow, we just put together Newton's first and third laws. But I think identifying the principle and of course the justification, guys, as good as it is, you get just 2 marks. Sometimes it may not be so good, but if it is reasonable, you get the marks. All right, again, guys, I said this is the topic where you just come and collect marks, but sometimes questions of this nature can throw you off. They are always there. So try to understand how to answer these questions at all times. All right, now let's move to the chemistry. Right. Question 5 says, letters A to F in the table, before represent 6 organic compounds. So the functional group here is this one, carbon double bond oxygen within the chain. This is a ketone. At this point, I don't care about what the name is. All I know is that this is the ketone, right? Because of the carbonyl group. Second one, ethyl propanoate. This is an ester. That's all I need. The next one is a branched hydrocarbon or branched alkane. That's all. There's No. Branched alcohol is a branched, okay, let's just say it's a primary alcohol, whether branched or not. This is a primary alcohol. Okay, now look at this one. We've got CH3 times 2. Now if this is times 2, guys, I don't know a structure that starts like that. Yikes. Okay, and then there's this carbon, and then this carbon has oxygen. Okay, it has the hydroxyl group. I think this one is incorrect. There's no way you can have CH3 times 2 like that. But anyway, we'll see. But it then suggests that these CH3 groups are attached to this carbon together. Okay, maybe. And then, which this carbon has an OH group attached to it as well, because normally I know how we move backwards. I never really saw this one coming, but we will see. And then we've got CH2, CH3, that's fine. So this is an alcohol, but this one is most likely a secondary alcohol. Okay, so we can say that this is a secondary alcohol. Then we've got butane. It's an alkane, we know it. This is F with just those C's with nothing. This is likely an alkyne. Okay guys, you need to know these molecules so well that you don't struggle here. 5.1 says define homologous series. Easy. Group of compounds that can be described by the same general formula. Nice and easy. Don't complicate your life. 5.2. These are definitions which actually should get 1 mark. To which homologous series does compound B belong? Esters. Right, 1 mark. So 5.3 says, draw a structural formula for compound B. Easy. Ethyl, we start with the the alkyl group. Then oxygen, have the carboxylic end. Propanoate, it should be 3 carbons. So again, how do we score marks here? We get a mark for the alkyl group, the alkanoate. Oh my lord, what else? The whole thing, I guess. This should be 2 marks though. Or one can say perhaps the functional group being correct, maybe. Some people do manage to mess this up. Okay, yep, it is what it is, 5.4. Now it says write down a letter that represents, this question is so common, 5.4.1. It says now an unsaturated hydrocarbon. Unsaturated, it's an alkyne. So this is going to be F. 5.4.2. A compound with the general formula CHN2NO. Now once this is a formula for alkenes, and with just 1 oxygen. Now this can be 2 things. It's a ketone and an aldehyde. Now here we've got a ketone, right? And the ketone that we have here is A, or which other one? Okay, no. This one is an alkane one, so we can't. It's just that one. That's the only ketone we have. Right, so that's A. Again, guys, easy 2 marks here. Nothing major. Can you see how easy it is to do this part of the question and be as fast as you can when you can? So write down the IUPAC name of compound A. Now we go on. Longest chain, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So if the straight chain makes up the longest chain, keep it at that. Second thing, we prioritize the functional group. It's in the center because see there's 2 carbons, then it's the third. 2 carbons is the third. Then we no longer prioritize it anymore. We prioritize a branch. From which direction do we meet the branches? From this side. So this is carbon 1, carbon 2, and then carbon 5. So easy. Now what is this? This is going to be 2-methyl right? 2-methyl pentane. What is this? How many? 1, 2, 3, 4, 5. Pentane 3-one. Right. So we know that our functional group is on the third carbon. That's why we say that. Pentane 3-one. Right. Nice and easy, guys. That's how we get to business here. So we get a mark for our side branch, mark for, placing our parent chain properly together with the position of our functional group. Right, so that was 5.5.1. Okay, so 5.5.2 says the IUPAC name of compound D. Wow. Okay, now we need to deal with this compound. So we've got CH3. To this C as well, we've got a CH3. Right? So there's 2 of those, and then this very same C has the hydroxyl group, and that same C is attached to the CH2, then a CH3. Okay, so of course you can put these guys in. I'm so used to just placing those hydrogens. Now there's a side branch. So this is what this looks like. Wow, that was strange. Let's see how many carbons. There's 2, 3, 4, 5. We've got 1, 2, 3, 4, 5. Good. Hydrogens, there's 6 plus 1, 7, 9, 12. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good. And only 1 oxygen. So that structure is perfect for the molecular formula or the condensed structural formula that we are given. So now, first of all, this is what should be priority, the OH group. Let us see, is it symmetrical? The answer is no. So if we come from this end, the alcohol is on the second carbon. Come from that end, it's on the third carbon. Of course, the longest chain is 4 carbons. So it's 1, 2, 3, 4. Or 1, 2, 3, 4, however you choose. So we're going to start from the side closest to the functional group. And of course, that becomes the side branch. So let's see. The name here now is a 2-methyl, right? 2-methyl, 1, 2, 3, 4. So butane 2-all. Yeah, butane 2-all. So this is 2-methyl butane 2-all. Nice and easy. So the substituent in the position of our functional group, and of course the parent chain. Nice and easy. So 5.5.3 says the balanced equation using molecular formulae of the complete combustion of compound E, butane. So butane is alkanes. So this is C4H, that is 4 times 2, which is 8, plus 2, which is H10, plus oxygen, giving us carbon dioxide, plus water vapor, right? Now let's see the carbons. Now remember, let me tell you something. The moment the number of carbons is even, this one is going to be a tsunami. Ne? It always ends up with those fractions you need to multiply by. Just remember that. If it was odd, then it would just balance out straight up. Okay, now let's see. We're going to have 4 here. And then the hydrogens are 10. We're going to need 5. See, that's why we end up with some fractions. Now let's see. This is going to be how many oxygens now? 8 plus 5, that's 13. And here we only have only 2. So if we put 13 here, we need to say 13 over 2, right? Now we multiply everything by 2. 2 goes there. The 2 disappears from here. We multiply this by 2, it goes to 8. We multiply that by 2, it goes to 10. Nice and easy. So always write a finished product. Don't show the steps. They're not necessary. Do it on the side workings and bring it here. As you could see, if you start writing other things, you may run the risk of being marked on the wrong workings and maybe to find that the final answer was correct. So in any case, let's check again. Is everything good? We've got 8 carbons. There's 8 carbons. We've got 20 hydrogens. There's 20 hydrogens. Now we've got 26 oxygens. Now we've got 8 by 2, 16. 16 plus 10 is 26. So everything is nicely balanced. So we get 3 marks here. Remember, this is 13, guys. It's not B. This is 1, 3. Okay. I'll just say 3 marks for everything, guys. Because the 3 marks is for balanced carbons, balanced hydrogens, balanced oxygens. Nice and dandy. So this is 15. Easy marks. As you can see, these are the questions, guys. You should not necessarily waste your time answering and wasting time exploring. It's either you go to them, you deal with them, but do you see compound F? Now in the exam, of course, you do what I'm showing you, but what I show you in the class when we explore everything, that's what you do when you study and practice. So there's 2 different things when it comes to studying and practicing and actually taking an exam, or at least simulating an exam. Okay, guys, let's not waste time. We don't have it. So we've got question 6. Now question 6 says the boiling points of various primary straight chain alcohols are provided in the table. And we can see this is 1 carbon, 2 carbons, 3 carbons, 4 carbons, and 5 carbons. So as the carbon chain increases, the boiling points are increasing, because these ones have similar and the same number of hydrogen bondings, but they only differ by the London forces. So the London forces are the forces that are actually determining the boiling point. Right, so now it says name. Write down the name of the functional group of alcohols. It's the hydroxyl group. Right? 6.2, easy 1 mark. Says define the term boiling point. This is the temperature at which the vapor pressure of a substance is equal to the atmospheric pressure. I remember when we were doing grade 5, standard 3. So what is climate? Climate is the condition of the atmosphere over a long period of time. It's called because as well as it is the condition of the atmosphere. Yes, atmospheric. If I am learned, why not say it? Atmospheric, Baba. Say it, Kabir. So that's good. So the moment you mention the vapor pressure equaling the atmospheric pressure is done. That definition is clear. 6.3 says, which one of the alcohols mentioned above is the least flammable at room temperature? Now, flammability is all about how easily is this substance going to form vapors, because if you look at a gas or something that can produce vapors, take for example methylated spirits. If you light a matchstick and you put it on, you will see that it only burns on the surface. It doesn't burn deep in the liquid, to tell you that it's only the vapors that burn. So the flammability is related to the vapor pressure. So this was a nice question. It says, now explain your answer by referring to vapor pressure. Of course, these ones kind of became too lenient. For me, they should not have asked this. They just said, they should have just said, fully explain your answer. That's all. Not say by telling us about the vapor pressure and risk of ignition. But again, the mark allocation is just saying, don't go to town. Okay, so which one is the least flammable? Remember, a higher boiling point is inversely proportional to the vapor pressure. So basically, the higher the boiling point, the lower is the vapor pressure. If there's a lower vapor pressure, then there's a lesser chance of flammability there. Right? If you leave it in the house, you can burn things. It won't catch the fire like it would for those highly flammable ones. Small chain hydrocarbons and all. Okay, nice and easy, guys. So we know that it's going to be pentane 1 all. Right? And the reason is that the higher boiling point means that it has a lower vapor pressure. You can say it has a low vapor pressure. It has the lowest vapor pressure of these molecules. You can easily say that vapor pressure is inversely proportional to boiling point. Sometimes you want to say these things. You can say, therefore, has a low risk, or the lowest risk. But let's not say that. Let's just say low risk or lower risk. It has a lower risk of ignition. Nice. You see? Easy stuff, guys. This is the mark and this is the mark. Technically, the mark is over there and then talking about the risk. Nice and easy, guys. As you can see, if this thing doesn't say explain fully, you don't have to go to town. Just pamanyana, you leave it. You don't kick it in the face, in the gut, everywhere. But once you hear that word fully explain, if you hear that word fully explain, you know you're going to have to talk about intermolecular forces, energy requirements, and the correlations of things until you get to that nice and dandy answer. Right. So let's get to this question. 6.4 says, use the information on the table to answer the following questions. On the graph paper provided, draw the graph of the boiling point versus Okay. Now I think let's just start on a new page. So this is 6.4. Let's go get it. We are the go-getters. Nice. Siyemos. Izwaketsi. Jwale he. Ke a rona he ha izwaketsi so. Re tsamaile le yona he. We pin it. And then we take it nicely and put it where it's supposed to go. Then this one must go away. Then let's expand you. Sengiqhela kaloku sana. Masokwengiqhela sana tyhini. Andingakubeki ugqibe wena ungahlali, yaqonda? Soxabana. We're gonna have a serious problem. A serious problem. So of course we'll put your name and all that. Right, so on the y-axis, remember the dependent variable is what follows the changes that you see. So this is the dependent. Now the independent is going to be the chain length, isn't it? Now this one says we need to draw the boiling point versus the number of carbons. Nice. So that's easy. So this is going to be number of carbons. And then of course it's going to say here boiling point in degrees Celsius, right? Right. Now, this is going to be tero, but sometimes you don't have to start at 0. Some numbers may be crazy, such that you don't enjoy this. But I'm going to choose here, let's see, if I decide this is 10, this is 20, 30, 40, 50, 60, 70, 80, 90, 100. Now we're going to 138, okay, 110, 120, 130, 140, 150, 160, 170, 180, 190, whatever. So if I say this is 10, I'm going to move over. Remember, these things I've put are just a means to an end. I'm going to wrap them off. So that's 10, 20, 30, 40. I'm going to put 50, 60, 70, 80, 90, 100. Okay. Yeah. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 110, 120, 130, 140, 150, 60, 170, 180, 190. That's fine. Now we're going to stop there for now. Then we want to deal with the number of carbons. I can say 1, 2, 3, 4. This is 1, 1, 2, 3, 4. 1, 2, 3, 4. This is 2. 1, 2, 3, 4. This is 3. 1, 2, 3, 4. This is 4. 1, 2, 3, 4. This is 5. Nice and easy. So this is 1, 2, 3, 4, 5. Make sure the graph is appreciably big so that there are no issues. So 1 goes with 65. So this is 50, 60. Okay, this is 50, 60, 65 is here. Right. Then the next one, 2 and 78. Where is 2? 100, 90, 80, 78 is somewhere there in between. Right, right. And then we going to go to the third carbon. It goes to 97. Just 100. 97 is somewhere there. Right, there is 97. The other one is 118. We go up 110, 120. Then 118 is going to be somewhere there. Right. And then last one is 138. Use a ruler sometimes to not get into trouble. 150. Oh, I've gone too far. See, I'm losing my path. What is that? 100. Come on, when I'm on. Come on, brother. Okay, I want to know what is this. So that is 100, 10, 20, 30. Right? It's 35, 38 is just above that. Okay, it's over here. Just needed to locate, but with a ruler you're not gonna go wrong. So this one is not the point. Obviously we need to draw these points nicely, but I can see these ones are almost in line. But there's a better way to draw this using the correlation coefficient. It helps us a lot to know how to do this, but the good thing is that we must not surpass the domain. So the starting point, the graph must end right around it or below it. And here we can see these points are taken. It must end with the last, because our domain is from here to there. So we cannot surpass the domain as we draw the graph. So that's essentially what the graph looks like. Try to join the most points this time around. But as you do statistics in term 2, you're going to learn about the correlation coefficient, and you will see that this graph will be drawn much better than this. But let's leave it here for now, because depending on your knowledge level, we don't want to complicate this thing. So 6.4.2 says, state the trend shown on the graph. This is easy. You can say as the number of carbons in the chain increases, the boiling point also increases. Right. Just go with the trend. Of course, if you want to talk about correlation, but this is a correlation, you can say there's a strong positive linear correlation. Nice and easy. But at this point, just be as simple as possible. Just say the number of carbons in the chain increases, the boiling point increases. You get a nice 2 marks. This one is 4 marks, right? Right. Now the last question. 6.4.3 says, explain your answer in 6.4.2 by referring to the type and strength of intermolecular forces. So again here, if it's not saying fully explain, we don't need to go to town. We just take the guidance, because we can see the mark allocation is not that much. Okay, so why is this the case? We know that an increase in the increase in the chain length increases the surface area. Surface, it's not surface. Surface area for intermolecular force. Intermolecular. Way my writing now is saying is late, guys. Intermolecular forces. Surface area for the intermolecular forces. or action. Right? Now that's the first argument. The second argument, we will say the weak London force strength increases. In addition, the weak London force strength increases in addition to one side for stronger or strong hydrogen bonds. Right, and so now what is the case here? More energy is required to separate. Come on, man. Whew. More energy will be required to separate the molecules of the longer chain molecules or compounds. Let's just say longer chain compounds. Can say therefore a high boiling point. Of course, you're not gonna write the way I am writing. Now I'm running out of space. You're going to say high boiling point as the chain length increases. But that's the conclusion we already are seeing. But now we wanted to put it to perspective. Alright guys, so that's as simple as that. So first of all, we need to talk about increasing the surface area. That's 1 mark. Talking about the type and the strength of intermolecular forces, including the hydrogen bonds. That's another mark. Then talking about the energy requirements and summing it up at the conclusion of saying that the trend is going to be like that. Okay, easy guys, we're taking these 15 marks. Again, this is a question you can answer without wasting time. Perhaps what chows a bit of time is the graph here. Alright, so let's move on to the last question. Now this is what gets a lot of students to tremble, but I think those who essentially follow this channel, they should already find it easy to handle those questions, because these I have done quite well since 2023. Until today. So every time I touched on this topic, I tried to go to town. Excuse me. I had to drink some water. You know, talking too much for long makes the mouth dry. Anyway, so guys, I've shown you how this works, and I'm sure you should be ready to do whatever needs to be done here. So let's look at question 7. Of course, guys, if you want this memo of mine, it's gonna be in the description of this video, together with this question paper for those who may want it. Now 7.1 says the following equation represents cracking. Okay, this question has been quite, I saw it in most of the question papers before, but yeah, it's here. Of hydrocarbons at high temperatures and pressures Right, so we can see this is, what is this carbon chain? 11 carbons. What do we call them? Oops, I forgot the name, guys. Okay, let's not even name it, it's fine. We normally stop at decane, but let's leave it. Let's leave it. Okay, that 11 chain compound. But now the problem is, okay, it's not the problem, it's fine. This is an alkane. Then we crack it. Now what we see here is an alkene, right? And what do we see here? What is this molecule? This is an alkane. So we've got an alkene and an alkane. So what is this molecule supposed to be now? So we've got an alkene and an alkane. So what is the likelihood of the other compound? Normally we can break it into an alkane and an alkene. But then if we've got a third one, most likely hydrogen gas, I think so. But if we look at these carbons, there's 8, there's 4 here, and then we've got 2 times 2, that's 4, that's 8. So if there's 8 carbons, 8 plus, wait, what is this? This is 4, not 8. So this is 4 carbons plus 4 carbons, that's 8. Now we are short of 3 carbons to 11. So this is a 3 carbon compound. Okay, whatever it is, if it is 3 carbon, it can be either an alkane or an alkene. We will find out. But I do believe it should be an alkane, but we'll see. Right, it says draw the structural formula of compound Y. Exactly the problem facing us. Okay, all right, okay. So what we have here is going to be 1, 2, 3. Now let's see. This guy has 4 carbons and 8 hydrogens. So we've got 8 hydrogens and 4 carbons on the one hand. Then we've got here again another 4 carbons plus 8 hydrogens. Not 8 but 10 hydrogens. Now to make up, how many hydrogens did this one have? 24. So let's see. 24 minus 18. It's 6 hydrogens. So we only have 6. So we can say this is 1, 2, 3, 4, 5, 6. Oopsie, it's not gonna work. Okay, we must have a double bond. Definitely it's an alkene. Okay, so this is 1, 2, 3. So this one is gone. 1, 2, 3, 4, 5, 6. Okay, that's what we have. So that's nice and easy. So can you see, guys, nice calculations there. So we only have 3 carbons, 6 hydrogens, by just calculating what we need to do. So 7.1, we know that this is going to be 1, 2, 3. We can put a double bond over there. So this gives us hydrogen, 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 hydrogen. So we are done. So guys, what is important is the functional group and the rest of the molecule. So 7.2 says now the flow diagram below shows the preparation of different organic compounds using compound P, which has the general formula Now you can see CnH2n plus 2. This means it's an alkane. Right. So compound P is an alkane. Now, when we react an alkane and a halogen, this is a substitution reaction. Right? You need to know the type. And of this substitution reaction is what we call a halogenation. Okay. Then we've got 2-chlorobutane. We know that it's only one halogen that's going to attach here. 2-chlorobutane. So this already tells us that this halogen is on carbon number 2. And this parent is a butane. So this already tells us that this is butane. Okay, nice. And then we are going to then take our 2-chlorobutane. This is an inorganic, by the way. So remember, we will substitute a hydrogen. So the hydrogen is going to pick up the other one. So it's going to be HCl. Hydrogen halide or hydrogen chloride or hydrochloric acid if you want. That's what is going to be there. And then we look at reaction 2. Reaction 2, we're taking our 2-chlorobutane and we are using a concentrated strong base. Now, if this is the case, this is an elimination reaction with strong heat as well. So this is an elimination reaction. Now, what we're going to eliminate is the hydrogen halide here. So it's basically a it's dehydrohalogenation, DHH. I mean, these reactions have been so common. So basically, this is going to form an alkene, right? That's exactly what this is going to be. Because if we use a concentrated, we eliminate. But if we use the dilute, we are going to substitute or hydrolyze. So this is an alkene. So I don't know why major product, of course, this says the poor gets poorer while the rich remain fairly rich, even under difficult times. Okay, reaction 3, we can see that we're using a dilute potassium hydroxide and of course mild heat. So this is going to be a substitution reaction, and specifically we call this one hydrolysis. Now, as you can see, I'm taking my time to do this. So obviously this is going to be an alcohol, right? Again, this one will depend on this. I mean, already the OH group is going to attach on the second carbon. So this is going to be a secondary alcohol, if you want. Secondary alcohol. Because the carbon that's bearing the OH group is a secondary carbon. So can you see, guys, with just understanding of these things so well from proper practicing, you know that you are winning. You know that you are winning. Is this big enough, guys? Can you see? Oops, yeah. Didn't notice it wasn't full. Now, do you realize, guys, we've done everything we can. So as you think about it, think of the reaction conditions, and you saw me writing them out as we were doing the thing. So let's see, 7.2.1 says, write down one reaction condition for reaction 1. Now remember, these ones are non-spontaneous reactions. We need UV light. What is the function of the UV light? Is to separate the halogen into its halide ions. That's the thing. Then once that happens, and of course it's also to upset one of the hydrogens on the molecule so that we can do the substitution. So at least UV light is necessary. Ultraviolet light. And of course, we just put this in the sun, nice and easy. So 7.2.2 says, is 2-chlorobutane a primary, secondary, or tertiary haloalkane? Obviously, this is a secondary haloalkane because the halide ion is attached to a secondary carbon. If it was on the primary carbon, which is the first carbon, then we would call it a primary. So this is primary. Sorry, secondary. It's a secondary haloalkane. Now the explanation is that the carbon bearing the halogen or the halide atom is bonded to two other carbons. That's the definition here. Because to say it's a secondary carbon, you're still not explaining it. So it's a secondary because the carbon bearing the halogen or the halide atom is essentially bonded to two other carbons. That's the key word here, two other carbons. And this is the one that bears the halide atom or ion. Right. So that's it, guys. We get our mark for the requirement, and we get our mark for saying secondary and for the explanation. So easy stuff. 7.3. 7.8. So this is 7.2.3. It says, write down the balanced equation using structural formulae for reaction 3. Now remember, reaction 3, once you hear that word structural formulae, this is only for the organic molecule, okay, or molecules. The inorganic ones, you don't do them with the structural formula. Anyway, let's do this one. So this is 1, 2, 3, 4. On carbon number 2, we've got a chloride ion or chlorine atom. Then we're going to add a potassium hydroxide. As we were told that this is dilute, you're going to put a D there. And then you show us that there's going to be mild heat also. But we were not told to show reaction conditions. So, but you know that we can also use ethanol as a solvent. Right? Because we have to treat our haloalkane. It's hydrophobic, right? It's not really fully soluble in water, so we need ethanol to treat it. Then we're going to have 1, 2, 3, 4, right, plus. Now obviously, let's see. We're going to have a few more things here. Damn it, man. Okay, let's do this. Let's take it a bit down so that we can use the space available. Right, I want to use the space effectively, so I don't want to end up squashing. So this is 1, 2, 3, 4. Of course, these are going to be hydrogens. Now remember, the OH group is going to substitute the halogen. The halogen is on the second carbon, so we're going to have our OH there, and then the rest. Okay, good. That's what we have here. We've formed our alcohol plus. Now, remember, the potassium is going to pick the halogen, isn't it? Those two love each other, so it's going to be potassium chloride. It's a salt, right? Now remember, in this case, this is going to be a salt, Emanyana bianu. What is cooking? Eh? What is cooking? I'm not happy now. What is this? What is this? What is this? What is this now? What is this? What is this? Something is not making sense. 2-chlorobutane. We substitute OH goes there. Yeah, this is perfect. Why am I panicking? Damn it, man. This is not elimination. So yeah, actually I was thinking of an elimination reaction. So this is perfect. It's done. It's dusted. That's what we get, guys. So that's it. That's it. So we get a mark for this guy. We get a mark for this product. We get a mark for the byproduct. And I suppose for suggesting that this must be dilute. But we're already given that. I don't know. Whatever, guys. It is what it is. Nice. So this one takes you a moment, but it's not a difficult question either. So let's do 7.3. Says reaction 2. Okay, we saw that that's elimination. In the flow diagram above is an elimination reaction, yes, during which the inorganic compound Q, the organic compound Q and 2 inorganic compounds are formed. Yes, the ones I was thinking for the first one. Write down the name of this type of elimination. I'm happy that. What is the name of this type? This is dehydrohalogenation. Dehydrohalogenation. Right, DHH. 1 mark in the bag. Come on, man. This is 7.3.1. Okay. 7.3.2 says we need the IUPAC name of compound Q. Now, we're going to deal with elimination. So with elimination, we're going to lose this guy. But which other hydrogen is going to accompany this? It's always going to come from the poor, right? Remember, even SARS bafethu izigwili azibhatali tax bazithanda ziyayekwa, but wena poor bakujaha bhalile ileta ezi-100. They are very patient with you, but izigwili baziyeka zona basijwayela. So with elimination, we're going to lose here. So it's the carbon with the least number of hydrogens. That's going to, of course, lose the hydrogen together with that. So it means our double bond is going to be right in the middle. So let's see. The IUPAC name now is going to be basically bute. This is going to be bute 2-ene. Nice and easy. All right, okay, all right. So that's as simple as that, guys. We are happy. So we get our 2 marks for the parent chain and the position of the double bond. Now we've got 7.3.3. It says the formula of each of the inorganic product formed during reaction 2. Now remember, we're going to lose a hydrogen alongside the chlorine, but there's a potassium hydroxide there. So that's a base. And then we're going to have HCl. So basically it's going to be a reaction between HCl plus KOH. What do we get? Strong base, strong acid. We're going to get salt, which is KCl, plus water. Nice and easy. So this is just going to be KCl and H2O because it's set formula. Nice. So we get our last 2 marks, guys, and we move on to sleep. Can you see, if you know these reactions well, which is never really difficult, it's a matter of just being comfortable with them. You can answer this question relatively fast, okay, with some strategies coming up, like with some questions, making it a bit less fast, because there you've got to consider things, and others is just a matter of general knowledge. So guys, this memo of ours is available in the description below, and of course you will catch the words as I mentioned them. Sometimes my writing is the worst, but I do think if you want to learn and check things out, you will be able to read it. But if you do not, what can I say? If you don't read, you don't study, you're not aware, you will be unable to read here. We'll have greater. I know how to write, guys. My writing was not so bad, but yeah, it died a miserable death when I got to varsity. It just died completely. It's even worse now. So guys, it's gonna be here, and of course if you spot any mistakes, let the dude know. And of course you can be as critical as possible if you want. I am one who can take criticism as it comes. I obviously do not take kindly to silliness, so don't try to be silly, but you don't have to be nice either. Otherwise we are good. Anyway guys, I hope you enjoyed the video. Give it a thumbs up, and of course study, and you may even consider subscribing to the channel, because there's a lot of beautiful things that if you were to take your time and explore this channel, you would see yourself flying high in Matric 2026. Anyway, it's your choice, guys. Let me love and leave you until next time. Dadai.